just looked at, right? So how do you graph them? Basically divide everybody by 16. Super illegal notation, but hopefully you got x squared over 4. Okay, so what does this tell you about this ellipse?
The center's at 0, 0.
Center's at 0, 0. That's your HK because of just x squared, y squared. Why am I going just over 2?
Yeah, because you can do square root of 4 is 2.
Square root of 4 is 2. Square root of 16 is?
4. So it's a root.
But isn't it nice with ellipses and with hyperbolas? If you ever get lost, you can always say, wait a minute, who are you under, right? The x is going to go the x direction horizontal, the y is going to go the vertical direction. What, Matthew? Oh, the major axis is vertically oriented, but as far as just the measurements themselves, it's a little shortcut just to look and say, like, oh, so the x kind of dilation sort of stretch. Then y. Oh, I see. Okay, it's messy, but there it is. Now, according to the question, where are we supposed to be rotating him about? Okay, now pause. There's a name to this axis for an ellipse. What would I use on the test? Because I'm not going to name x or y. I would say go about the major axis. It's the longer one. What name, even before you write it, if you have it memorized, what name is this ellipsoid going to have? Major? They both get paid for playing. Prolate. Some of you need to, wait, pause. You've been studying your formulas. Now what do you need to study? The names. No, just the formulas from 10.1, 10.2, 10.3, 10.4.
Can we just write the words? Those words?
No, you can't, because it's a fill-in-the-blank test. Good try.
Write it in Hebrew.
Nope. Nope. Okay, the formula card tomorrow has to be in English, number 1, using math in English, number 2, and using formulas from 10.1, 10.2, 10.3, 10.4, fitting in one of the 4 categories that I just showed you that I wrote down today, with the exception of expanding the asymptote line equation. But I did let you do diagrams of hyperbolas, parabolas, ellipses, 2-dimensionally.
Oh, you can draw those?
2-dimensionally. Yeah. But you can't do twists or spins or names. Does that make sense? Oh, yeah. Sorry, it was in context of this, and I was like, yeah. Diagrams of 2-dimensional, that's okay. Just no twists and no names, yeah? It gives you very little to study tonight, besides problems and how to use the formulas, right? Okay. You guys good, my artistic and non-artistic ones about how to draw this guy? Just this, put here. And then if you want to, you can make it nice and pretty and bring fun things in order to actually rotate. But do you need to make it nice and pretty? No, I just need to see it. Prolate, ellipsoid, check. Any questions? Why is it called prolate? Yeah, just for the ellipsoid. There's an oblate one. Oblate. I think of obtuse, oblate, but then I think it's actually oblate. But that's the one if you were going about not the major, but the minor. And that's the big fan blade. And that one, how do you show? If it was going about the minor. Remember, you can just do the whole like, shoop, shoop, and then be like, yay. Make it like a wheel. Right? It just goes whoosh. Okay. Someone said double helix. You can do that too. Okay, so how about cone? Did you guys make this look a lot prettier for yourselves?
Yeah.
I would have. Wasn't it helpful in section 10.1 with the whole m equals tangent theta, or the tangent theta equals m2 minus m1, to get it in a nice y equals mx plus b form, right? But this one's just plus 0 because who is this guy going through? And it is going to go from, Matthew is helping us out, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Rise is 1 as you run 2. Rise is 1 as you run 2. Rise is 1 as you run 2. 2, 4. 4. and then 6. Going to 6 that way, I'm going to 6 that way. Where's this guy supposed to spin? So where do I put the spin? Right here, of course. Where's he going to go? To go meet the other line. You see him? Take that rotation and just put him in. Put him in, and then there we go. Our cone has been flipped down. Those were the evens. Any other questions on 12.3? Oh, 11, the bonus one? Okay, we can peek at them for just a second. Didn't I add that in the Google Classroom instructions? Yes, extra credit 11. Number 11, here he is. He's on both sides, huh? He's a little bit here and a little bit over there. Let me go steal this one first. And then let me go steal the second half. Oh, there's a picture. That makes life a little bit nicer. Boop. I know, I'm sorry. That would have made life a little bit easier for some of you guys. Let's see. What do we have? We have a triangle hitting at an xy. We have a y equals 9 minus x squared parabola. The vertex is at the origin, is at 0, 0. Area of the triangle. So A equals 1/2 base times height. That's geometry, but I need to somehow get this into like an f of x. So I see the base right here, right guys? Doesn't x figure out how far over to a point and y figure out how far up to a point? So if this is x, how many x's do I need to have my entire base? Yeah. Yeah, x is half of that base, so I can go ahead and say that my base is actually going to be 2x. And then my height, well, hold on. Isn't the height the same thing as just the y? So y. Because x goes from the origin out. So if it was the point 3, 4, I would go over 3, up 4, which is only half the triangle. So I have to double it. And I have to go the other way too. Now, I have a y and it says only as a function of, but here's the cool thing. What do I know about y and x and how they're related? Plug it in, plug it in. So a is equal to 1/2 times 2x times 9 minus. You can make it look pretty if you want, like a equal to. But the long story short is where they're trying to have me find. Find the value of x that. What really nifty tool do you have that helps you find a max? Ooh. Do you guys know another reason I'm letting you have a formula card on the thingamabob tomorrow? Because aren't there formulas hidden in your calculator anyway? Now, is it to everything like foci and directrices? And no, I'm being super nice. But I was like, that way no one has like undue advantage if you know how to use your, oh, why isn't he coming up? Sorry, guys. Let's try again. Take 2. I'm trying to find the max of this guy. Now, quick, your calculator does not have an a equals. It has a y1 equals, right? Now, we're going to basically say y1 is a, but that's just something to take note of. Okay, so if I was to go ahead and do this in my calculator, I would throw in to y1, let's get rid of that, my x times 9 minus x squared. And I want to find the max. Okay, zoom standard. Shoop, shoop. Dun, 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 dun. Aw, I can almost see him. I think I'm going to have my y's go just a little bit higher. Dun, 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 dun. Max. Isn't there a cool feature for that in second trace? Can't I go ahead to number 4, right? Yeah, number 4. Boop. And then I have to go left. No. I just need to go around it, right? A little bit to one side and then a little bit to the other. Boop, boop. Sorry, one more. Boop. So now I have x equals 1.7320525 when y equals 10.39. So I'm just going to do this. I'm going to steal them and say, well, that's very helpful information. I'm going to go ahead and take it over here. and say, how do we use said helpful information? Well, x is x, right? So x is x, that's good. So find the x that maximizes, check. And then it says find the area. I don't know area. I only know y. I only know y, which is a in my calculator. So that's a. Dun, 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 dun. So for your information, it's in the video, right? If you want to pretend and not pretend, if you want to, it's not the right word. What am I trying to say? Yeah, challenge yourself and figure out the bonus to homework and maybe a bonus tomorrow. Not a bad idea. Good question. Let's go ahead and talk about that test tomorrow, huh? So all these formulas, well, in some variation, hopefully looking in a very prettier, much nicer, much clearer way on a formula card. You're going to have those ready for me. But what else is going on in the test? Let me pull up the test review, which you guys technically could have started over the weekend. Should have probably started over the weekend. And I will go over questions if you guys have any in just a second. So if you guys need to be writing it down, there's the test review. If you need to be grabbing a book, you can go on up now. But Chapter 10A. Okay, you will have formulas as long as you make them. You will be allowed to have your calculator. Now hold on. What was Section 10.1 again? About lines and inclination and angles. Uh-oh. Angles. Degrees or... Well, yeah, you can throw the cheaters. Me on your card. Well, you have your calculator. So technically you can find sine of... It'd be easier to go the other way. I guess I don't mind the cheater chart because you're allowed to use your calculator. Like, yeah, I don't mind, I suppose. Oh, sorry, but there are going to be some that are like decimal angles. Guys, just keep an eye out. If the angles have degree marks, what mode do you need to be in? Okay, and if you're not, it's not going to look right, right? So just double check your mode if you see degree marks. But otherwise, you're going to have some matching with clues to formulas. Clues to formulas. This is sounding more like Section 10.2, 10.3, 10.4, because wouldn't they give you clues like, here's the focus, or here's the directrix? And if they say something like, something's at the origin, like the vertex or the center, that's a clue too, right? Okay. So going from clues to equations, those would be good homework problems or examples to look at. What if I give you equations and ask for clues? Well, then you're going the other way. What if it already has the x minus h, y minus k stuff? You just need to know, oh, I just got rid of them, but all the formulas and how to plug in, right? What if I give you something about, oh, this one's a little confusing. What if I give you a major axis or minor axis length? What am I talking about? Do you remember that from homework? The major axis or minor axis length. That's an ellipse, right? Major, minor. And the length, am I talking about halfway, like the AB, or the whole way? The whole way. Okay, so if I gave you one of those, you have to cut it in half to be A or B, right? Major would be A, minor would be B. What's my advice whenever I give you clues? Sketch, because that way you know whether it's moving horizontally or vertically to like the foci or the vertices or things like that. Does that kind of make sense? Okay. We already talked about eccentricity. Nicely done. We already talked about, oh, what if I give you guys one of those nasty ax squared plus by squared plus cx plus dy plus, how? Complete the, she's alive. Complete the square. We'll talk about formulas later. Complete the square. So if I give you one of those nasty ones, complete the square. Hey, what if it's like, what was that homework? Was it 10.4? Where right at the end of homework it said like, hey, look at the equation and tell me the conic. Remember those ones? Is it a circle? Is it an ellipse? Is it? You might want to study those ones. No. Because you can write the standard forms, but not like, it's up to you whether or not you want to memorize that. You know what I mean? Like there was a way of, yeah. So it's up to you whether or not you want to do the ones in the book. Okay, long answer. You ready? Yep. Priscilla, we're just talking about the test so you can get the hints from people. Oh, yeah. Never mind. I'm recording. Good call. Okay, long answer. You know how in homework for section 12.3, the one we just graded, you had to get the parabola or the ellipse or the hyperbola first and then spin? On the test, I give you the ellipse or the parabola or the hyperbola. So you don't have to go through all the work of graphing it. But you do have to pick the right axis to go around. How do you pick an axis if I tell you transverse or conjugate or major or minor? How do you pick it in a picture? Remember the little rotation arrow? You pick it with an arrow. So you might want to make a note to yourself that when you graph, when you spin for section 12.3, pick it with an arrow. So you're going to have to pick the right axis. I'm going to give you conjugate or transverse or major or minor based on the picture I give you. You have to pick the right axis with the rotation arrow, and then you have to show me the correct three-dimensional picture. Is it a bowl? Is it a two-sheet or a one-sheet, two bowls, or the hourglass? Is it the football or is it the fan? You have to show me the correct three-dimensional, and then you're going to have to name it. Now, paraboloid, do they have different names? It's just paraboloid. But ellipses and hyperbolas, they have different names. Prolate, oblate, two-sheet, or one-sheet. So that's part of the long answers, is just sketching, and then you have to know the names that go with the sketches. And then the other one, you ready? I'm not going to tell you what, but it is a conic section written in the nasty form that needs completing the square, where I want all the characteristics identified and a picture. I want all the characteristics identified and a picture. And just in case you're like, we never did that. Hold on, we did that for every single section except for the spinny one. Meaning, didn't we, calm. Didn't we take a guy and didn't we complete the square and then, well, he was degenerate. I'm not going to give you a degenerate one on the long answer. But we could have done him. You guys definitely had him in homework. For ellipses, didn't we have one of him too? And you had to tell me stuff and then sketch? So it's going to be a parabola, an ellipse, or a hyperbola. The nasty form, complete the square, sketch, and identify. You guys good? Yeah. All right, get out of here. Bye, guys.
Thank you, Mr.
P.S. That whole max crazy number 11, not in the test at all tomorrow. Bye. Nehemiah. Oh, no, Nehemiah. Huh? I don't think I'm subbing unless something comes up today. So try me, Lauren. I should be. Priscilla, I see you, kid.